Okay, next problem. It is number 6. Step 1, picture. Let's read the problem. A friend drives by at 20 meters per second, and you wish to catch up after starting from rest in your car and accelerate at 2.5 meters per second squared. How much time passes before you just catch up to your friend? How far do each of you travel from your starting point before catching up? So this is a little bit of a, it's getting a little complicated. So, this is like I'm gonna look at this from like from on top. So we have our friend, and they are moving at, I'll just call this VF, the velocity of our friend. Here we are, I'm gonna call this me, and what is our initial velocity? It's 0, right? But they're moving by us like this, and we want to catch up. We're starting from rest, so we need to accelerate, right? To catch up to our friend. So I'm gonna write a double arrow right here with an acceleration. Let's call this AM for me. Okay, now I'm gonna use a little bit of color here. The final point of this story is that we catch up, right? I'm gonna write our caught up picture right here. We're at the same position, right? We're at the same position. F and me. But in between, how does this look? Are we moving together the entire time? No, we're not. This is moving at a certain velocity, and we're starting from rest, and we need to like catch up, right? So we go like this. Does that make sense? I feel like if you drive, it makes sense, right? So at like, this is our first and final, but in between, when our friend is right here, we're most likely like still over here, right? Because we're still trying to accelerate. And then eventually we'll catch up. Okay, what is our friend's velocity right here? It's the same. They're not accelerating. Velocity is constant. We start with V0, and we now will have a velocity. I don't know what to call that. V2? I don't know. Let's just call it V2. And the other things we need to be considerate about. Okay, we travel a distance of x. The problem is asking for x. We also, time passed. We don't know how much time passed. I'll circle these. Yep. Okay. Let's write our knowns and unknowns. Known. Let's look at our friend first. Friend's knowns. V friend. Oh, that's confusing, isn't it? Using F. Oh. Well, that's part of the practice, I guess. Assigning them and like making sure you understand what we're talking about. So this is V friend. Okay, V friend, what is that? 20 meters per second, right? 20. Are they accelerating? No, we're not gonna write that down. Okay, now let's look at us. What is our initial velocity? 0, we are starting from rest. And we also accelerate, right? And they tell us what that is. 2.5 meters per second squared. Meters per second squared. Okay, unknowns. The problem is asking us how much time passes. We need to find t. How far do we travel? X. I don't know if this is going to be relevant, but I'll just write it down. V2. We don't know what our velocity is when we catch up. I don't know if that's relevant, but okay. Step 3, equations. V final equals V initial plus acceleration in time. Displacement is V initial t plus half of AT squared. The third one, V final squared. This is V final, that's not V friend. I know that's confusing, but I apologize. I should have picked something different. Initial squared equals 2AX. Okay, this is a confusing one, and I apologize. Step 4, we need to solve for, what are we solving for? How much time passes? We want to solve for t. Okay, let's look at our equations. Question, is the time going to be different for you or the friend? No. We're talking about the same friend, so it doesn't matter which person we look at to find out the time, because it's the same time, right? So let's look at our friend. V final, we know that because it's constant. V initial, we also know what that is. Oh man, this is, yeah, V initial, we know that. Acceleration, is our friend accelerating? No, they're not. So this would be 0. We're looking for t, but if this becomes 0, this will just become 0, and we can't use this, then we can't find t, right? Let's look at number 2. Displacement, x. Do we know x? No, we don't know x, and we're looking for t, so we can't use number 2 either. Same thing with number 3. We don't know, well, this doesn't even include time, so we are faced with a problem. I can't use these equations in a straightforward way to figure out the time. So what do? What you have to do is use these equations in a way that you can find out the time. So what do I mean by that? We can't use number 1, right? Because for our friend, they don't have an acceleration, so t would just go away. I'm not going to use number 1. I'm going to look at number 2. The displacement of our friend can be described as this. And our displacement can also be described as this. Do we have the same displacement? Yes. We move the same amount, right? From the beginning to the end, we move the same. So the displacement of our friend equals my displacement. Okay, but now what, right? So what if these x's equal each other, can I write, well, I can write down my friend's variables for this and equate it to my variables for this. I know that's confusing, but let me write it down and see if you can understand it. So we got VI. I'm gonna first write, this is the left side is friend. What is their V initial? That's VF, right? 20 times T, that's what we're looking for, time plus half of, oh, sorry, I'm gonna rewrite that. I kind of skipped a step. Okay, sorry. V of our friend times T plus 1/2 of AT squared, a friend, you know, and me, V0, right, our initial velocity, I called that V0, V0T plus half of acceleration of me, and the time squared. You don't need to put any, is it a notation for t? Because that's the same, right? We both traveled the same amount of seconds. So now let me plug in my numbers. V, F, T, V final. We know our, I'm sorry, I said it, V final. No, it's V friend. V friend, 20, right? Right here. T plus half of, what is their acceleration? They don't have an acceleration. That's going to be 0. T squared equals, what is our initial velocity? That's 0, right? We started at rest. 0 t plus half of, what is our acceleration? They told us it's 2.5. 2.5 t squared. We can get rid of these and these, right? Because they're multiplied by 0. So I'm going to just write it as 20t from here. These are zeros. And then half of 2.5 t squared. Okay, this is just, algebra here. What am I gonna do? I'm gonna clean this up. So we have 20t equals 1.25 t squared. We have t on both sides of the equation. That means I can divide by t and get rid of one of them, right? So if I divide by t, it becomes 20 equals 1.25 t, because we get rid of that squared. Okay, and now we just divide both sides by 1.25, and we should get something like 16 seconds. That is how long it took for me to catch up to our friend. Now part B. How far do we travel? That is asking for the displacement of x. Do we travel a different amount of distance? No, we're looking at positions when we start and when I catch up. If we're caught up, we move the same amount of distance, right? So it doesn't matter how you solve this, whether you solve it using your variables or your friend's variables. I'm gonna choose to look at our friend because they don't have any acceleration. We know our time, so I think we can solve this pretty easily. Let's look at our equations. V final, we do know, because they're staying constant, right? V initial, we also know. Acceleration, they do not have an acceleration. Oh, dang it, I did it again. We're looking for x. We don't need to look at equation number 1 because there's no x in there, so sorry about that again. Let's look at number 2. That is what we are looking for, x. Vi, the initial velocity of our friend, that's Vf. We do know that. We do know the time, right? We just solved for that. And half of acceleration and times squared. They're not accelerating, but we can use this equation, right? Because that just becomes 0, and this is our answer, right? And I hope you guys can see where this comes from. This, velocity is distance over time. If I multiply both sides by t, that just becomes vt of distance. That's this, right? Displacement equals velocity times the time. Distance is velocity times the time. So that's that. So let's use number 2. Displacement equals v friend times time and the acceleration, which of course is 0, but I'm still gonna write it anyway. Okay, our velocity for our friend, it was 20. How long did we travel for? 16 seconds. And this is all gonna be 0, right? So we just multiply 20 times 16, and then we get 320 meters. That is how the distance it took for me to catch up to our friend who was traveling at a constant velocity.